The last two examples in this section are asking us to find a particular solution for the differential equation that satisfies an initial condition. All that means is that we're given some kind of initial condition or a point on the original function so that we can solve for c. In WebAssign, you're going to still be asked to enter your solution as an equation, so just make sure that you're entering it in with that equal sign. For number 5, we have that our differential equation is y prime plus xy minus 2x is equal to 0, and our initial condition is y of 0 equals negative 5. This says when x is equal to 0, y is equal to negative 5. Again, that's the point that we're going to use to solve for c. This is our differential equation, so we're going to just separate variables and solve that differential equation. Instead of y prime, I write dy dx plus xy minus 2x is equal to 0. Well, I want to isolate dy dx. I want to get this all alone on one side of the equal sign. So I'm going to move the other two terms over to the right-hand side. So I get dy over dx is going to equal positive 2x minus xy. Now notice both of these terms have an x in them, so we're going to go ahead and factor out an x from those two terms. dy over dx is equal to x times 2 minus y. Now it's time to separate the variables. I need all my x's together, and then I'm going to need all my y's together. If I multiply both sides by dx, I get dy is equal to x times 2 minus y times dx. Dividing both sides by 2 minus y, and I get dy over 2 minus y is equal to x dx. Now we can integrate both sides because we've separated variables. The left-hand side is going to require a u sub. We're going to let u equal the denominator there, 2 minus y. Then the derivative du would equal negative dy. Well, I don't have a negative dy, so I'm going to multiply both sides by a negative. And negative du is equal to positive dy. So this becomes the integral of negative du over u. And this guy here, if we integrate, that just integrates as x squared over 2 plus c. Integrating du over u, we get negative natural log of the outside value of u is equal to x squared over 2 plus c. Get out of u's and go back into y's, and you get negative natural log of the absolute value of 2 minus y is equal to x squared over 2 plus c. Now let's use the initial condition to find the particular solution. What we're told is that when x is equal to 0, y is equal to negative 5. So we can write negative natural log of the outside value of 2 minus negative 5 is equal to 0 squared divided by 2 plus c. This is negative natural log of 7 is equal to, that's just 0, c. So that means that c is equal to negative natural log of 7. Now I don't need the absolute value anymore because 7 is a positive number. Therefore, that particular solution is going to be negative natural log of the absolute value of 2 minus y is equal to x squared over 2 minus the natural log of 7. Number 6 gives us the differential equation, the square root of 1 minus x squared times y prime is equal to y over the natural log of y, where y is greater than 0, and the initial condition is y of 0 equals e squared. So this portion right here, y greater than 0, is just letting you know the numbers that can be plugged into your function, so you don't have to worry about this part here. It doesn't have anything to do really with how we separate variables or how we find the solution to the differential equation. So we're going to go ahead and separate variables and find the solution like we normally do. I'm going to rewrite the radical as the 1/2 power. I'm going to rewrite y prime as dy dx, and that's going to equal y over the natural log of y. I'm going to multiply both sides by dx because I need to get that out of the denominator. Now I need all of my x's on the same side, and I need all of my y's on the same side. So I need to multiply by the reciprocal of this guy, so we get the natural log of y over y dy, and that's going to equal dividing by this guy, dx over 1 minus x squared raised to the 1/2 power. Well, now we can integrate both sides because we've separated our variables, so integrating the left and integrating the right. The left-hand side is going to require a u substitution, and the right-hand side isn't a u substitution, it's actually inverse trig. This is actually the inverse sign, because you can rewrite this as dx over the square root of 1 minus x squared, which leads us to think inverse sign. Now, since the inverse sign, we use the letters a and u. I won't use u for the u sub on the left-hand side. It's good practice to use a different letter, so I'm going to go ahead and use w to do the substitution on the left-hand side. Anytime the natural log is present, that is always going to be what you choose for your substitution. So we're going to say w here is equal to the natural log of y, so dw is equal to 1 over y dy. So then this guy here is going to equal the indefinite integral of w dw. And then over here, we know that a squared is equal to 1, because remember, a is always the constant, and a is equal to 1. That u squared is equal to x squared, because u is always the variable. U is equal to x, and your du is equal to dx, which is perfect, that's what you have. So then this is going to equal w squared over 2 equals, over here, this is just the inverse sign of u over a plus c. Getting out of w's and going back into y's, we end up with the natural log of y squared all over 2 is equal to the inverse sign of x plus c. Plugging in that initial condition, we're told that when x is equal to 0, y is equal to e squared. So we have the natural log of e squared quantity squared over 2 is equal to the inverse sign of 0 plus c. Well, here the natural log and e cancel, and this is just 2 squared over 2 equals the inverse sign of 0 is 0 plus c. Well, 2 squared over 2 is just 2, and I don't need that 0 there, so that means that c is equal to 2. Therefore, the particular solution is the natural log of y squared over 2 equals the inverse sign of x plus 2. That's that particular solution. We can also write this as the natural log squared of y over 2 equals the inverse sign of x plus 2. Either one of these is correct. That's it for separation of variables.